Hey guys, and welcome back to the OOP-NPC tutorial series. In the last episode, we created a loop structure and completed some other preparation that we will now utilize in this episode. We will create a loop that can be run to make an NPC follow a part. If the part can be moved to in a straight path without using pathfinding, then the NPC would choose not to use pathfinding. Otherwise, if pathfinding is needed, then we'll code the NPC so that it uses pathfinding. This episode is a bit on the long side, but it will cover the entire process of setting up this loop for following parts, and this same loop for following parts can be used to have an NPC follow a character, such as the player's character. But nonetheless, let's get right to the video. To get started, we'll create a function called followPart. The parameters will be the part to follow, whether or not to include siblings when detecting if the part can be reached via a straight path using raycasting, and an optional override for the raycast params, though we won't be using that override in this series as we'll just use the default raycast param function we created. All in all, this function will create a new loop that will make our NPC repeatedly follow a specific part on repeat. We will then be able to stop following that part by removing this loop, and because of how the loops table is set up in the new function, then only one of these specific loops will be able to run at the same time, preventing the NPC from trying to chase multiple parts at a time. Inside this function, we'll configure a new loop called followPart, and specify the properties as part, include siblings, debounce, and raycast params. We'll then define a function to run when the loop is called. Inside that function, we'll do what we did when we were testing last episode, and return if the debounce property is true, setting it to true afterward. Then we'll set the debounce to false at the end again, but this time without the cooldown, as we don't necessarily need a set cooldown for this function, but rather just want to prevent it from running on top of itself in the case that it takes more than one frame to complete. We'll define variables for the NPC's character objects, such as the character model itself, the humanoid, and the humanoid root part, returning if the humanoid or root part weren't found so as to prevent errors from the NPC dying. Scrolling back up to the top for a second, we'll add a new value to our base NPC module table called followDistance, which will be the distance from the part that we want the NPC to walk up to, as we don't want the NPC to walk to the part's exact location, but just walk up to it and then stop right next to it instead. Back in our followPart loop, we'll create a variable called goalPose. We'll set it to the part's position by accessing it from the properties table. Then we'll add a few studs to that in the direction from the NPC facing the part being followed by using .unit and multiplying it by our followDistance value that we just defined. Now we'll create another variable called params, setting it to the raycast params property if it exists, or the result of our getDefaultRaycastParams function if it doesn't. Make sure that you add a table with the part to follow in the arguments of this function, as we want to make sure that the part itself doesn't get excluded from the raycast. The reason the part might be excluded from the raycast is in the case that we use this followPart function to follow the humanoid root part of another NPC. Since all NPCs are added to the exclude list in a sense, then we want to make sure that this part, and whatever NPCs it may be inside, is not getting added to that exclude list as well. Moving on, we'll create another variable called goalDir, short for goal direction. We'll define it as the direction from the NPC's root part to the goal position that we defined earlier, using our trusty unit property yet again. We'll define another variable for the goal magnitude, which is essentially the distance between the NPC and the current goal position, this time using the magnitude property rather than the unit property. Finally, we'll create a variable called result, setting it equal to the result of a raycast. For the origin, we'll use the NPC's root part origin, and for the direction, we'll use our goalDir variable we defined, multiplying it by the goal magnitude that we also defined by adding 5. The reason we add 5 is because the goal position, which goal magnitude is based off of, doesn't actually quite reach the part in question, and we want to see if this raycast will hit the part without hitting any other parts. Finally, for the last argument, we'll add the raycast params that we stored in the params variable. And after all that, we'll take the moveToJanitor that we created earlier and run its clean function. This will complete any tasks that have been given to the janitor. The idea behind this moveToJanitor is in case we make the NPC try to walk to one location while it's still walking to another. moveToJanitor will be used to store tasks that need to be completed in order to stop the process of moving to one location before moving to another. In this case, we want to clean any chores it may have before making the NPC then try to chase the part in question. The NPC may be in the middle of running the moveToLocation function, in which case we want to stop that function by running the clean method of this janitor. Now we're going to create an if statement. We want to check essentially if the raycast result hit anything, but we also want to account for hitting sibling parts instead of the exact part we're following. The reason we need to do this is because imagine if we use this followPart function to chase a player's humanoid root part. If we raycast to try to hit a player's humanoid root part, chances are we'd hit a different body part instead, like the arm or the torso. For that reason, I added this includeSiblings parameter to the function to allow it to account for anything inside the character model as a whole, rather than just the single part being chased. And so the resulting if statement has a few parts to it, but let's break this down. There are two conditions that we need to check. The first is that the raycast actually hit something, because if it didn't hit anything, then we already know that the part isn't in sight. Next, we need to know if the thing that was hit was either the part we are chasing, or the includeSiblings parameter is true, and the raycast hit a sibling part like the arm or torso. That's basically what all this Boolean logic is doing. And note how I'm using parentheses in the if statement to group up bits of logic to make sure it evaluates each Boolean in the right order to achieve the goal that we're looking for. Now, the actual goal behind this if statement is to determine whether we need to use pathfinding or not in order to move to the part. If we don't need to use pathfinding, then there's no reason to, as it just creates unnecessary lag. If this if statement runs, that means we don't need to use pathfinding, and so we'll set the moveDirection attribute to the direction we need to move to reach the part, and then move the NPC to that goal position using the humMoveTo function. Now we'll add an else to this if statement in the case that a straight path is obstructed, meaning we would want to use pathfinding to have the NPC navigate to the part being chased. We could just run the moveToLocation function we made earlier, but the issue with that is that how it's set up makes it difficult to update the location being moved to over time. In the case that we're chasing a player, that player is going to be moving around, and moveToLocation doesn't account for that, so in this else portion of the if statement, we're going to create a bit of a variation of how moveToLocation is set up, but using a lot of the same stuff. We'll start by creating a protected call to calculate the path using the computeAsync function like before. If success isn't true, we'll give a warning and return to end the function. Now we'll use the getWaypoints function to calculate the waypoints along that pathway and set the current path waypoints value to that table of waypoints so the distance of the path can be calculated if needed. Then we'll create a variable called firstPoint, which will be the first waypoint along the path, and set it to nil for now. We're essentially going to find the first waypoint in this pathfinding path and only move to that one, ignoring the rest. There are some slight issues, like with jumping, that arise from this, but it's the most effective alternative I could find and seems to work a lot better than if we were to just spam moveToLocation every frame. In order to find this first waypoint, we'll use a for loop through all the waypoints in the waypoints table. Then, if I is not equal to 1 and the distance between the current waypoint's position and the NPC's position, ignoring the y-axis, is greater than 2 stubs, then we'll proceed to set this waypoint as the first waypoint and then break to end the loop. The reason we want to ignore any waypoints that are less than 2 studs away is because I came across some issues when playing around with this, where the first waypoint was in almost the exact same location as the NPC, and thus only moving to the first waypoint meant that the NPC would just stand around and not move, if I remember correctly. Sometimes, ignoring waypoints less than 2 studs away leads to issues with jumping over obstacles right in front of the NPC, but I played around with the minimum distance and 2 produced about the best results I could get. After all that, we'll check if the first waypoint variable isn't nil in the case that there wasn't a point found that was further than 2 studs away. Afterwards, we'll set the move direction to the direction from the NPC's position facing the waypoint that we are going to move to. Then we'll check if the .action property of this first waypoint is jump, and if it is, we'll run the moveTo function on the NPC's humanoid and then set hum.jump to true. We'll then wait for the moveTo function to be finished using the moveToFinished event. We'll then add another check in this if statement that checks if the action property of the first waypoint is walk instead, in which case we'll just run humMoveTo to move to the first waypoint's position, but we won't wait for the moveToFinished event this time. If the first point variable is nil, however, then we'll change the moveDirection attribute on the NPC character to be an empty vector3, signaling that the character isn't moving anymore, likely because they already reached the destination. Now we'll want to utilize configureLoop's last argument, which is a function to run whenever the loop is removed from the loops table. This function will have the same properties table from before, but it won't have the dt or delta time variable, since this function only runs when the loop is removed and not every frame like the last function. We'll use a while loop to repeatedly run task.wait while the debounce property is true, just to wait for the last move to be completed if necessary. After that, we'll set the moveDirection attribute to an empty vector3 to make sure the rest of the code knows that the NPC isn't moving anymore. We'll also set both the current path waypoints and current destination values to nil again, since the NPC won't be moving anymore if this loop is removed. And now finally, to test this function to see if it works, we'll create a new part inside the workspace and give it a specific name so it's easy to find from the script. In the code, in the base NPC:new function, we'll run the followPart function using this new part we created as the part to follow, accessing it directly from the workspace. We don't need to use any of the other arguments for this quick test. When I test it, I get a small error, which is because I used the self keyword instead of the NPC variable. In all functions below the new function, then self refers to the NPC object itself, and using self would have worked, but in the new function, self refers to the base NPC module itself, or a module that inherits from base NPC, which we'll get to later in the series when we cover class inheritance for these NPCs. But anyway, replacing self with NPC, we'll try it out again. As we can see, the NPC does in fact chase the part, but it doesn't seem to be stopping the running animation when it actually reaches the part, which likely means the moveDirection attribute isn't being set back to an empty vector3 like it should be. The reason for this is because when the NPC is walking a straight path, in the case that pathfinding isn't needed, then it never actually sets the move direction back to a 0 vector if the destination has been reached. At the top of the code, we'll create another value under the follow distance called the follow distance margin. If you're familiar with statistics or anything, then the reason I call this the margin is in reference to the margin of error. In this case, the distance is going to be the distance from the goal position, which we will consider to be close enough because it's within this margin of error we created and are going to account for. We'll set this value to 2, just like down in the pathfinding portion, where we checked if each waypoint was greater than 2 studs from the NPC's position. Down in the pathfinding portion of this followPart loop, we'll replace the minimum distance of 2 we specified earlier with our new follow distance margin value we created. After that, we'll head to the portion of the followPart loop that makes the NPC walk a straight path. After the move2, we'll create an if statement that checks if the distance between the NPC and the goal position, ignoring the y-axis again, is less than or equal to the follow distance variable, which would mean that the NPC has reached its destination. If it is, then we'll set the moveDirection attribute to an empty vector3. In the else portion of this if statement, we'll cut and paste the part from above that set the moveDirection attribute initially. We'll put it in the else portion instead, so that it only runs if the if statement doesn't go through. Testing it, we can see the NPC following the part, and even as we move it around, the NPC continues to follow the part. But in order to test the pathfinding portion, we'll need to create an obstacle, so I'll create a small wall between the NPC and the part. Upon testing it with this new small wall, we can see that the NPC walks around the wall. Anytime the part is out of sight, the NPC begins using pathfinding to navigate to it, but then when the part is in sight again, the NPC walks directly in a straight path to the part without using pathfinding. And now, if I fast forward and create a small maze sort of thing, then we can test the capabilities of this pathfinding a little bit. Upon testing it now, we can see that the NPC is able to navigate through the maze to reach the part. You can feel free to test around with the pathfinding and see how it works for you. I forgot to test jumping in this recording, but it should roughly work as well if you want to test that on your own by adding obstacles that are small enough to jump over throughout the maze. Additionally, feel free to test around with having the NPC chase the nearest player's humanoid root part on your own. We'll get into this more next episode where we create a new class of NPC known as an aggressive NPC that will chase players upon sight. For now, we'll remove the portion in this base NPC called a new function that runs the followPart loop, as we know now that it works fine. That will be the end of this episode. This video was a bit longer than usual, but I wanted to finish the followPart function since I figured that was a good milestone to stop at. If you're struggling following my videos, or you just want one-on-one support in your projects with a scripting tutor, then feel free to check out my membership offers on YouTube and on Patreon, both of which you could find more information on in the description of all my videos. Additionally, you can get access to tutorial files, like for this one, by purchasing the $299 a month membership on either YouTube or Patreon, or any of the higher memberships as well. Even if you don't purchase a membership though, you're supporting me just by watching my videos, so thank you for watching. If you have any questions or run into any troubles that you can't figure out on your own, feel free to join the Discord server in the description as well to post questions where I, or anyone else who might be available, can help you out.